All right. So a few more topics I wanted to cover with lines, right? Again, some of you maybe yesterday you saw in the homework that things we didn't do. One of those things was writing the equation of a line given certain pieces of information. All right. So for example here, I'm just going to jump right in. I'm not going to title these because these are just kind of continuation from yesterday. In fact, if you want to continue your notes from yesterday, feel free to do that, you know. All right, anyway. All right, write the equation of the line given the following. All right. So, first example, and we're just going to do like two, okay? We'll say the line intersects the points -2, 6, and 4, 9. Okay, 2, 6, 2, -2, 6, and then 4, 9. All right. All right, so there's many options that we have to write the equation of a line. If you remember yesterday, we talked about two different forms that we could use, right? We had slope-intercept form, and then I also was encouraging you to use point-slope form. But we'll hold off on point-slope form for right now. We'll just focus on that slope-intercept, and then I'll show you point-slope. All right. So to write an equation of a line in slope-intercept form, what pieces of information do we need? We need to find a slope, and we need to find the y-intercept, right? Slope-intercept form, that's what you need to write the equation of the line. All right. Do we have the slope in our given information here? Are we given the slope? No. Are we given the y-intercept? But aren't these y's? Why can't I put those in? They're not y-intercepts, right? Those are y-coordinates, but they're not the y-intercept, right? If this was a y-intercept, what number would have to be here? 0, right? Okay, a y-intercept is on the y-axis, right? The y-axis has points that have x-coordinates of 0 because it's on the y-axis. And so we can see here, these are not y-intercepts, they're just random points on the line. So we have to come up with the y-intercept as well. All right. So we're going to have to find the slope. Slope, remember, right, is like, you might remember it as like rise over run, okay? Or you might think of it as like the change in y over the change in x, maybe, is another way to think of it too. Okay, the rise is how much your y values are changing. The run is how much your x values are changing. And to show the change, we're just going to do a difference, right? So it'll be, y2 minus y1 over x2 minus x1. So in this case, 9 minus 6 over 4 minus -2. Also the average rate of change formula too. Remember that back from Algebra 2? You asked to find the average rate of change on things. Well, average rate of change is also something that will even show up in calculus as well, should you, continue on after pre-calc to calculus. Anywho, 9 minus 6, 3, 4 minus -2. I'm going to make that plus positive 2, so I'll make that 6, and that simplifies that into 1/2. All right, so slope-intercept form, we've got y equals 1/2 x plus our y-intercept of b. All right. And we still need to find, though, that y-intercept. We've got our slope. That's m, right? But we need to find that y-intercept. Okay. How can we find our y-intercept? What can we do at this point? Any ideas? Yep, go ahead. Plug in one of the points into the equation. Exactly right, Sydney. And you said it doesn't, so you're kind of indicating it doesn't matter which one, right? Right, okay. And so by plugging it in, so give me, as an example here, what could I put in for y? A 9, okay. And you know that because it's the what? Yeah, it's a y value, y coordinate. And then what then must go in for x? 4, right? Okay. We know already, if this is going to be the equation for our line, we know that these points must work in that equation, right? It's got to make the equation true. So we can assume that 4 can go in for x, simultaneously then 9 must go in for y, and then that means now we have an equation we can solve for b, right? Before, we couldn't really solve this equation for b, or at least get a value for b, because we had 2 other unknowns. But now without those unknowns, we can solve here. So 9 equals 2 plus b, and so b equals 7. And so our answer, our equation, 1/2 x plus 7. Okay, easy peasy. Now, that's slope-intercept form, right? Let me just show you. Point-slope form, we were done right here. We don't need to find the y-intercept because point-slope form requires that you have a point. Do we have a point on our line? Yeah, we got two of them, right? We got 2 points. Pick one. And then the slope. And we just found the slope. So we don't need to find the y-intercept for point-slope form. Let me just show you. Again, point-slope form is y minus y1 equals m times x minus x1. Okay. I'm just going to pick a point. I'll use the same point that Sydney did there. We'll use the 4 and the 9. Okay, so y minus 9 equals m, we said was 1/2, x minus 4. And there's the equation of the line in point-slope form. Okay. These are describing the exact same line. If you don't believe me, you can simplify, right? Distribute the 1/2. We get 1/2 x minus 2. And there's the y minus 9. Add the 9 over. Negative 2 plus 9. I'll put a little plus 9 there. Negative 2 plus 9 is plus 7. Right? And there you can see. It's the same thing. Same thing. Okay? But you can save yourself a little bit of time by not having to write that, find that y-intercept. So, questions on any of that? All right. We'll do one more example here about writing the equation of a line, and then we'll move on here from writing the equations of lines. All right, again, here's just another like kind of random piece, kind of bringing in some stuff from yesterday. Let's say our line is going to be perpendicular to y equals 2x minus 4 and intersects the point 5, 7. Okay. Oops, I'm off the screen. Just about off the screen. Okay, so let's say our line has got to be perpendicular to y equals 2x minus 4, and it's going to intersect, our line will intersect the point 5, 7. Okay? All right, so what do we know about lines if they're perpendicular? What can we say is true about the two lines if they're perpendicular? Go ahead there, Parker. The slopes are opposite reciprocals. So the slope of this line that we're given is what? 2. Positive 2, right? And so what will our line's slope have to be then? Negative 1/2. So right away, without having to do any calculations except for that little mental arithmetic, okay, mathematical gymnastics there, we flip it, make it the opposite. So negative 1/2 is our slope. Okay? And then, oh, this is easy then, right? Y equals negative 1/2 x plus 7. There's the equation of our line. Right? No. 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 Is this point a y-intercept? No, okay? And again, I do that because I see you guys do that, okay? Well, maybe not you individually, but collectively, it'll show up sometimes, okay? Watch out there, right? That is not the y-intercept. That is a y-coordinate. So this is not the equation of our line. We got to then, okay, say y equals negative 1/2 x plus b. Then plug your point in. 7 equals negative 1/2 x, or sorry, 5 is 1/2 there, plus b. So, oh man, fraction, Mr. Wid. It's too much, right? But we need to be able to do them. Negative 5/2 plus b equals 7. Okay, so we'll add the 5/2 over. I'll go ahead and make 7 into 14/2 plus 5/2. And so b is 19/2. And so we get y equals negative 1/2 x plus 19 over 2. Okay. Or if you like, 9.5. Negative 1/2 x plus 9.5. Okay. Questions on any of that? Questions on any of that? Okay. Let me see, bless you, let me see if I have a system of equations here to show you just as an example, because I don't want you to not solve that. Okay. Looks like I don't have one. I'll just do one from the homework. I'll show you one from the homework, then I'll do that. Okay. Just to make sure we're all okay with this stuff. Okay. So, all right, we'll do this one here. So, solving a system of equations. Again, we're just kind of picking up like some kind of random tidbits here. Okay. Just to make sure we're okay. Okay. Although some of you did in the homework already last night, so. But anyway. All right. So, this is one of the homework questions. So you're welcome. All right. If you haven't done this one yet. It's number 21. Okay. We have several strategies for how to solve a system of equations. If we have our graphing calculators available, one option is we could graph each of these. Right? So that's one option. You could graph. All right, and locate the point of intersection. Okay. Right now, of course, are these in a format that we could graph using our graphing calculators? No, right? In order to get them in the right format, we need to do what? Yeah, solve for y. Get y by itself. Okay, so you would do that. Okay, I'm not going to do that though. I think you guys are, okay with the graphing calculators, or if not, then I'll be happy to show you another time. I just don't want to spend time on that right now. Instead, we have other options. We could also use a method called substitution, right? Where we're going to take one of our variables in one of the equations and solve for it. Now, looking at that first one, it's pretty easy to solve for x here if I just add y over. So if I make that x equals 2 plus y, then I can take that 2 plus y, and wherever I see an x, I'll replace it with 2 plus y. So for example, right here in the other equation, I can instead write 6 times 2 plus y minus 5y equals 16. Okay, so that's a substitution here. Distribute the 6, so we get 12 plus 6y minus 5y equals 16. And so we get 12 plus y equals 16, and so y equals 4. Okay. Once we have that y is 4, how can we get the x, the matching x coordinate? What can we do? Yeah.
You plug your input y into the equation.
Yes, Isabella. Yes. Doesn't matter which equation we plug it back into. No, it doesn't. So I would suggest plugging it back into this one because it's already solved for x. Right, so we know that x is going to be then equal to just 2 plus 4, so x is 6, and so then our answer is the point 64. Okay, so in other words, if you were to graph those two equations, the point of intersection would be the point 64, where they would intersect. Okay. Do systems of equations always intersect at a single point? Okay, no. So what are some other options that we could experience? So yeah, go ahead, Julia. Okay, right. So in a system of equations, a system of linear equations, two linear equations, right, our lines will be parallel. Since there's no point of intersection, there will be no solution there. Exactly right. So either one solution or no solution, right? They'll be parallel. Is that the only two options for a system of equations? Yes. Yes, or infinite solutions. What's that scenario, Sydney? If they're the same line. So that means that they have the same slope and the same y-intercept. Right, that'd be infinitely many solutions because if they're the same line, they intersect at an infinite number of points. Okay, right. Okay. And then I'll show one other method here because this one is kind of nicely set up for it. I'm just going to do this one real quick. But there's also elimination. Okay, elimination where I can get the coefficients to kind of match up, but I want them to be opposite. So for example here, if I multiply the top equation by -6, okay, if I multiply the top equation by -6, I end up with -6x plus 6y equals -12, and then I'll keep the bottom equation the same. Okay. Now, since the -6 and the +6 are opposites, if I add these two equations together, the -6 and 6 will cancel. 6 plus -5 is 1y, -12 plus 16 is 4, and so I get y is 4. That's what we had right there. Right? And so then ... you'll know that x is going to be 6. How do you get this x equals 6? You can plug the 4 in there, or plug the 4 in there, and solve for the x that way. Okay? So that's another option, is using elimination. All right? It's really just a matter of choice at that point. Okay? The more options you have, the better it'll kind of go. All right? So, any questions on any of that? All right, and again, I know I'm going fast, but some of this is review, so I don't know. I'm trying to like balance taking the time to go over some old things, but also moving on quickly so that way we don't, we get to the other stuff that we need to get to today. All right. So that covers what we need to cover yesterday. And now we'll get into what we're going to do today, okay? Which is circles. Circles, okay? Did you guys talk about circles at all in Algebra 2?
No.
Yes, no, a little bit? Okay, like, no, the unit circle, but what about the equation of a circle? Some, okay. Geometry you maybe did, okay, but I forget Algebra 2 if we did or not. I don't remember 2. I don't remember what we did. I don't even remember anymore. It was just last year, right? But anyway. Circles! Okay. So it's kind of a weird place to bring in circles. All right, it's kind of weird. But there is a relationship to the previous information that we've done so far and circles, okay? Specifically the distance formula. All right. But we're going to jump right in here. We'll give you the equation of a circle. Okay, so centered at the origin, which is, of course, coordinates 0, 0. Okay, the equation for a circle will be x squared plus y squared equals r squared, where r is the radius of the circle. Okay. Now, this is a bit of a funky way to write an equation for something, right? Typically, the equations or the functions that we're used to seeing are y equals and then stuff with x, right? So like y equals x squared, it's a parabola, right? Or y equals x, it's a line, those kind of things. But when it comes to us writing the equation for a circle is kind of a different kind of beast than most of the things that we talk about, okay? Quadratics, right? Parabolas are functions. Lines are functions. Is the graph of a circle a function? Yeah, so I see some no's, right? It's not a function, okay? If you remember, of course, one of the quick, easy ways to determine if something's a function, right? If you can take the graph and if you draw a vertical line through it, right? If it hits more than once, and in a circle, you potentially hit it twice, right? Then this thing's not a function, right? It fails the vertical line test. And so because this thing's not a function, the way that we write it is kind of a little bit different than the way we normally write things. Okay, that kind of it makes it a little bit different. Okay, you can solve for y here. It just, we typically write it this form because it's helpful. All right. So some things we should be able to do. We should be able to sketch a circle. So x squared plus y squared equals 16. All right. So to sketch something, right, we're just going to draw coordinate plane there. The center of our circle is at 0, 0, so I'll go ahead and drop a point there at 0, 0. And the radius for our circle is going to be, I hear 16, I hear 4. It is 4, right? Because r squared is in the place where 16 is. So 16 is r squared, which means if we square root both sides here, r is 4. Again, we're not going about the plus or minus part. It's an equation, but a negative radius would make no sense here, so we just leave it plus 4. All right, so how do we sketch a circle? Well, I'm just going to go 4 to the right, 1, 2, 3, 4, and put a point, and then go up 4, 1, 2, 3, 4, and put a point, and then down 4, 1, 2, 3, 4, put a point, and then left 4, 1, 2, 3, 4, and put a point. Okay, that's all I really need you to be able to do. Don't worry about, diagonals, and then just kind of connect the dots in the most circly kind of way that you can. Okay, so yeah. Something like that. And that's all I'm expecting from you there, okay? Nothing too crazy. Nothing too crazy. I guess I should put an x-axis and y-axis there. Okay? Something else you should be able to do. Write the equation of, excuse me, a circle with center at 0, 0, and r equals the square root of 107. Okay, so go ahead and take like 15 seconds and write the equation of that circle there. All right, centered at 0, 0, radius is the square root of 107. Go ahead and write the equation of that circle. Give it a shot. Volunteers on this one? Any volunteer? Want to share what they got? Go ahead there, Megan.
X squared plus y squared equals 107.
X squared plus y squared equals 107. Are we all okay with that? Yes, it's right. Okay, that's very good there. All right. Knowing it's centered at the origin, that just means it's going to be the x squared plus y squared there. And then the 107, right, that is r squared. If the radius is the square root of 107, then r squared is 107. Be very careful. I find that students like kind of, get the which one's supposed to be r squared and which one's supposed to be r. I feel like they get that like mixed up all the time. If you're in the equation, r squared is what you got or what you need, right? If you're trying to find the radius, then you need to do just r by itself, right? Okay. So in the equation, it's got to be r squared. Outside of the equation, just talking about the radius, you just want r for the radius. All right. Now, this form you'll need to have down, all right? I recommend, though, that you don't worry about this one, okay? Because this is a very, very specific case where the circle is centered at the origin, right? But instead, consider just remembering this version where it's not centered at the origin. Okay, consider this, okay? And we'll say instead, x minus h quantity squared plus y minus k quantity squared equals r squared. Okay. In fact, maybe what you guys were thinking I was going to write in the very first place would be this, right? And maybe I should have. Maybe I should just skip the first part altogether. Because really, if you know this one, you know the first one too. Okay, in this instance, the center has coordinates hk. And the radius is r. Right? So the radius is still r. Center, though, is the point hk. What you can see, right, if h is 0 and k is 0, then it'll be x minus 0 or just x, and y minus 0 or just y, and that's where we get the x squared and the y squared by themselves, right? If h is 0 and k is 0, because that would be the origin for the center, and then just be x squared plus y squared equals r squared. So really you don't need to worry about, knowing both things, just know the one. Okay? So as an example here, we should be able to identify a center and radius of the circle, or the center. It's not more than one. Okay, so for example, if I give you the equation of a circle, we're going to avoid completing the square today. Tomorrow we will be completing the square. Okay, I don't know if you guys remember working on stuff like this before, and you had to complete the square and things. Maybe just the phrase "complete the square," makes you break out into a cold sweat a little bit. We'll get to that tomorrow. So you can breathe easy today. Okay. All right, using this information here, what will the coordinates for the center of our circle be? You want to have a volunteer? Go ahead there, Stephen.
-3, 1.
-3, +1. Yes. Yes. Okay. Remember here that for the center to be h, it's got to be x minus h. We have x plus 3. How can I make that minus something? Remember, plus a positive is the same thing as minus a negative. Whoops, minus a negative. So -3 is really our x-coordinate there. And then we do have minus k, right? Our minus is -1. So 1 is the center y-coordinate. All right? And then, Steve, you want to go ahead and give us what's the radius there? 6. Radius is 6. Okay, again, r squared is 36, so r would just be 6 there. Okay. All right. And of course, you should also be able to write the equation of a circle given the center and the radius. I guess I'll show that one here real quick too. I don't want to skip anything. All right. Write the equation of the circle with c, -4, 5, c for center, and radius of 11. So why don't you guys go ahead and do that, all right? Take like 2 seconds, write the equation. Once you've finished writing down the directions, I guess, okay? Write the equation there and just do it. All right, keep rolling here. Excuse me. So, moved it all around. There we go. Okay. Should have been x plus 4 quantity squared plus y minus 5 quantity squared equals 121. All right, questions on any of that? All right, I got 2 more problems for us here, and then I'm going to cut you loose onto your assignment, okay? And hopefully we should have some time for you to work on things. Looks like we're going to have that work out today. All right. All right, so finally something a little more interesting. Well, I guess in my opinion. All right, a circle has center at 3, -1, and a point on the circle at 2, -2. Oops, I'm off the screen. There we go. What is the equation of the circle? Okay. So we've got our center. Got that. What other piece of information do we need, though, to write the equation for the circle? The radius, right. Okay. So, any ideas about how we could find that? All right, let's go to Hayden first. Distance. Okay, distance between the 2 points. Because what is the radius but the distance from the center to a point in the circle? Okay, absolutely. Let's use the distance formula. All right, distance formula. D equals, can you set that up for us, Hayden?
D equals 2 minus 3 squared.
Okay, 2 minus 3 squared.
Plus -2 plus 1.
So minus -1, which becomes +1 squared. And so we'll simplify that. 2 minus 3 is -1. Squared is going to be 1. Negative 2 plus 1 is negative 1 squared is 1. So it's the square root of 2. So that number that we found, that distance, that is the what again? The radius. Okay, so that's going to go into our equation for our circle. And so it'll be x minus 3 squared plus y minus negative 1, or I'm going to put plus 1 squared, equals, and then what number should go right here? 2. Right, that's supposed to be r squared, right? So if that's r, then r squared is going to be 2. Okay. Did anyone have a different idea about how to go about finding the radius here? So, yeah, go ahead there, Andrea.
Input the points into your equation.
Yes. Alternatively, if we start with the known information there, x minus 3 quantity squared plus y plus 1 squared equals the radius squared, right? We have this unknown r value, but we also have an unknown x and an unknown y. Okay, but Andrew's exactly right. This point must work. Just like we used that idea when we were finding the y-intercept, right? We plugged a point in to find the y-intercept. This point has to be on our circle. It must work in our equation. So you can put the 2 in there. You can put the negative 2 in here, and that is going to equal our radius squared. Okay? Wow, this calculation looks an awful lot like what? The distance formula. In fact, if I square rooted both sides here, it would be exactly the distance formula. The equation of a circle is the distance formula. Okay? In so many, words, I guess, or so many, symbols and stuff. Why? Well, a circle, if you remember back from geometry, a circle is the set of all points equidistant from a single point. And so what do we do in the equation of a circle? We have the distance formula is equal to a particular number, and it's always equal to that constant particular number, okay? So it's the set of all points that are equidistant from a single point. The equation for a circle is just the distance formula there, okay? So if we finish solving, 2 minus 3 is negative 1 squared is 1, negative 2 plus 1 is negative 1 squared is 1, equals r squared. So 2 is r squared. I don't need to square root both sides because what do I need to write the equation? I just need r squared. So I don't need to solve for r. I have r squared. I'm just going to plug it in up here. X minus 3 squared plus y plus 1 squared equals 2, just like we had over here. Okay, same. Not very good at circling. Questions on any of that? Too easy. Right? All right, well, one more here. All right, a circle has endpoints of a diameter at 6, 0 and 0, 10. Okay. Circle has endpoints of a diameter at 6, 0 and 0, 10. What is the equation of the circle? Now I've made it even more challenging. Last problem, I was nice and I actually gave you the center. You just have to find the radius. Did I give you the center here? Nope. Do I give you the radius here? Nope. So, ideas here. What could we do? How could we proceed? Let's go back there to Mark.
Can you find the distance of the entire, one side of the circle to the other side of the circle? And then,
So you're saying find the distance between what 2 points here? You're saying
6, 0 and 0, 10.
And what will that distance represent? The length of the what?
The diameter.
The diameter. Okay, so we can do that. We can use the distance formula here. So one option here, okay, is find the diameter by using the distance formula. D equals the square root of, and I guess I'll do 6 minus 0 squared plus 0 minus 10 squared. How do we do it over here? Okay, so 6 minus 0, it's 36 when we square it. 0 minus 10 is negative 10, squared is 100, so I get 136, or the square root, sorry, of 136. Okay, so that's the diameter, but what do we need? Radius, so what can I do with the diameter to get the radius? All right. Diameter is twice the radius, so we'll divide by 2. So then r equals the square root of 136 over 2. Okay. I wrote that kind of sloppy. Let me do it again. All right, we've got the radius. What do we still have to find? Center. Okay, and how can we find the center? Let's go over here, Cindy. What do you say?
You could use the midpoint formula with the diameter.
Right, because with the midpoint of the diameter, that's where the center is, right? The diameter goes through the center of the circle, and so there's a radius on either side of that center to create the diameter. That is the midpoint. Yeah, so we could use midpoint formula to find the center. So we'll do 6 plus 0 over 2, and then 0 plus 10 over 2. Oh, I'm sorry. Thank you, Katie. Yep. And so that becomes then 3, 5. All right. And then we can write the equation of the circle. X minus 3 squared plus y minus 5 squared equals r squared. So the square root of 136 over 2 squared. So we can leave it like that, right? We've answered the question. But I'm going to simplify it just because I can. You can. Squaring a square root cancels it out, so it's just 136. Squaring the 2 there is going to give us 4. Okay. And then let's see here. 136 divided by 4. What's that? 34. Thank you. Arithmetic. Okay. And so there's our final answer, simplified and stuff like that. Okay. Did anyone have in mind a different strategy than the one we took here? Anyone have in mind a different strategy than the one we took here? Hayden, what are you thinking?
I just found the midpoint first and then found the distance.
Aha. So find the midpoint and then therefore the center first, and then you said you did the distance between what 2 points?
The center and one of the other.
And one of the points. And that will give you the radius straight away, as opposed to having to divide by 2. Yeah. Okay. So that's the other way you could possibly do this here. Midpoint first, and then do the distance from the midpoint to the one of the points on the curve. Or you can do like Andrea suggested earlier, where you can find the midpoint and then plug in either 6, 0 or 0, 10 into the equation, and then solve for the radius that way as well. So either way. All right. Questions on any of that? All right, so that is it. Believe it or not, we made it here, and you guys will have some time to get started on your assignment. All right, so let me give you what that's going to be here. I believe. Yes, page 22, 69 to 81 odd. Page 22, 69 to 81 odds. Okay, that's what a little O means whenever you look at the calendar or something like that, right? If you end up doing the evens, then you did extra practice. All right, good job. Oops, sorry, didn't mean to kick your backpack. So if you want text, there are some textbooks in the back. If you want to like go back there, take a picture of the assignment, and go from there. Or like I said, you should be able to pull it up on the PDF in our Google Classroom as well, and you can get started on it that way too. All right, so.